Hello everyone, I miss you. Today we'll be doing a lesson on simplifying fractions. That's section 1.1. Your homework is listed here. Please finish them and take a photo of your work and upload onto OneNote. Okay, so first of all, let's go over a few definitions. The first one is fractions. Fraction is a number that represents part of a whole. Okay, and fraction is also one way to write a ratio. We'll learn ratios later in chapter 4, and we'll talk about that more in chapter 4. So, an example of a fraction could be 1.4 or 3 over 6, etc. Okay, numerator. Numerator is the top number of a fraction. So, for example, if my fraction is 1.4, then my numerator will be the 1 there. Okay, and next, denominator. Denominator is the bottom number of a fraction. So again, let's use 1 over 4 as an example. So my denominator then will be the 4. Okay. Next one, proper fraction. A proper fraction is a fraction where the numerator is less than the denominator. So something like 2 over 5. The top number 2 is less than the bottom number 5. This is a proper fraction. Okay, and an improper fraction is a fraction that is greater or equal to 1. So the value is greater or equal to 1. And what does that look like? It looks like this. So an improper fraction will have a numerator that is greater than or equal to the denominator. So for example, if I have 7 over 4, the top number is greater than the bottom number. Okay, and if I have 6 over 6, the top number is the same as the bottom number. These will all be called improper fractions. Okay, next one, prime numbers. Prime numbers are numbers that are greater than 1 and can only be divisible by 1 in itself. So for example, 2 can only be divisible by 2 and 1. Okay, 3 can only be divisible by 3 and itself. And there are more. So 5, 7, 11, 13, 17, etc. Okay, composite number. Composite number is a number that's greater than 1 and that is not a prime number. So for example, 4, 6, 8, 9, etc. Okay, so you guys will need to know these definitions in order to do the rest of this unit. Okay, so now let's look at some fraction diagrams. So a fractional diagram is a diagram that shows a fraction. For example, the first diagram here, the red part, the shaded part is half of the whole thing, half of the circle. Okay, the second one, the shaded part here, it's a quarter, 1/4 of the square, the big square. And the next one is a third of the circle, and this one is a half of the triangle. And the middle one, let's count how many parts there are in this circle here. It's 1, 2, 3, 4, 5, 6. So in total, 12 parts. And 6 parts are shaded. So it will be 6 over 12. And the next one, one section is shaded, and there are a total of 4 pieces. And the next one will be 1/5, 2/4, and 3/4. Okay, you guys will need to know how to read the fractional diagrams. Okay, now let's move on to the next one. Next one is improper and proper fractional diagrams. So if we look at these two diagrams, the first one is a whole that's been divided into what? 6 sections, right? And the shaded area are 5 sections. So it will be 5 out of 6. Okay, what about the next one? The next one, our circles are being divided into 3 parts. And how many parts are shaded? If you count that, it will be 1, 2, 3, 4. 4 parts are shaded. And each circle is divided into 3 pieces. Okay, so this is 4/3. Now you guys may have noticed already, for our first diagram here, it's 5/6. The top number is less than the bottom number. So this is a proper fraction. The second one, because the top number is greater than the bottom number, so this is called a improper fraction. Okay, you guys may notice already that an improper fraction like this actually is more than 1. So it's 1 and an extra piece, right? Okay, so the next section is to simplify fractions. Okay, so let's write down what the fraction for each circle is then. The first circle, we have a circle that's been divided into 3 pieces. So how many are there? 1, 2, 2 parts, right? So it'll be 2/3. And the next one, the fraction is being divided into 6 pieces, and we have 4 shaded ones. Okay, and the last one, the fraction is being divided into 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces, and the shaded areas are 1, 2, 3, 4, 5, 6, 6 of them. And if you guys compare these 3 diagrams, you can see that these 3 diagrams are actually equal to each other, right? The shaded areas and the unshaded areas are the same. So we can say that these 3 fractions equal to each other. Okay. So 4/6 could be reduced to 2/3, and 6/9 could be reduced to 2/3 as well. Okay. So how do we simplify a fraction without using a diagram? There are 2 methods. The first method is by using the greatest common factor, GCF. Greatest common factor. Okay, so what we're going to do here is we're going to look for the common factors of the numerator and the denominator and find out which one is the greatest. So for example, our first question here, the factors of 4 are 1, 2, and 4. And the factors of 6 is 1, 2, 3, and 6. Right? So what's the greatest factor that's in common? It's 2, right? So what we're going to do here is we will divide both the top and the bottom by 2. Okay? So that will give you 4 divided by 2 is equal to 2. 6 divided by 2 is equal to 3. Okay, so if we simplify 4 over 6, the answer will equal to 2 over 3, which is the same as what we've done with the diagrams. 2 over 3 is the same as 4 over 6. Okay, and let's try the next one. So 12 has factors of 1, 2, 3, 4, 6, and 12. What about 30? 30, we can have 1, 2, 3, 5, 6, 10, 15, and 30. What's the biggest number that's in common? What's the biggest factor that's in common? We can see that 6 is in both of those list of factors, right? So 6 is the greatest one. So now what we're going to do is we can divide both the top and the bottom by 6. And so 12 divided by 6 is 2. 30 divided by 6 is 5. And we've reduced our fraction to 2 over 5. We've simplified our fractions to 2 over 5. Okay? All right. And the reason that we can divide both the top and bottom by the same number is that we know if the top and the bottom are the same number, then it's equal to 1. So actually, 2 over 2 is 1. 6 over 6 is also 1. So we're actually just dividing by 1. It doesn't change the value of your fraction. Okay? All right. Now, let's learn how to use prime numbers to simplify the fractions. So the way we can use prime numbers to simplify fractions is that we will need to find the prime factors of each of the numerator and denominator. So let's draw a factor tree. Let me do the 30 first. So 30 can be seen as 5 times 6. 5 times 6 equal to 30. Okay, and 5 is already a prime number. You can't reduce it anymore. But 6 can still be factored. 6 is equal to 2 times 3. Okay, so now we know that 30 is equal to 2 times 3 times 5. Okay, and let's try 105. 105, if you factor it, we can divide it by 5. If we divide 105 by 5, then we get 21. And if we divide 21 by 3, then we get 7. Okay, so 21 is equal to 3 times 7. We know that. Now let's write that down. So 105 is equal to 3 times 5 times 7. Okay, what do you guys see here? We can see that 30 is the product of these three numbers, and 105 is a product of these three numbers. So now, because we have a few products in common, we can actually cancel the products. Okay, so 3 and 3 can be canceled. 5 and 5 can be canceled. So what's left? The number that's been left on top is 2, and the number left on the bottom is 7. So 30 over 105 can be reduced to 2 over 7. Okay, let's try another question. Okay, 18 is equal to 6, 3 times 6, and 6 is equal to 2 times 3. Okay, so the top will be 2 times 3 times 3. Now let's look at 48. 48 is a product of 6 and 8. 6 is a product of 2 times 3, and 8 is 2 times 4. Okay, so what's in the bottom? Bottom we have a few things actually. We have 1, 2, 3, 4, 4 twos and 1 3. So 2 times 2 times 2 times 2 and a 3. So now let's cancel anything that's in common. Okay. Now remember that you can only cancel them in pairs. There is a 2 on top, we can only cancel a 2 on the bottom. We can't cancel all the 2's. We can only cancel 1. Okay? What else do we have? We have a 3 on top, we have a 3 in the bottom. So we can cancel the pair of 3. And now what's left? Okay, the only number that's been left on top is 3. And the numbers that's left in the bottom is 2 times 2 times 2. We don't really like to leave our final answer as a product, as a multiplication of numbers. So I want to just re-multiply these together. So 2 times 2 times 2 is equal to 2 times 2 is 4 times 2 is 8. 3 over 8 will be our final answer. Okay, 2 more questions. 30 over 12. You can use either one you like, actually. So you can either use the greatest common factor method or you can use the prime numbers method. Okay, so let's just use the prime numbers method for these questions. So 30 is 5 times 6, and 6 is 2 times 3. And then 12, we have 2 times 6, and 6 is 2 times 3. Okay, so let's write that down. So that will be 2 times 3 times 5, and then the bottom is 2 times 2 times 3. And let's see what we can cancel. We can cancel a pair of 2's, we can cancel a pair of 3's. So what's left on top is just 5, and on the bottom is just 2. Okay, last question. 40 is equal to 2 times 20, and then 20 is 2 times 10, 10 is 2 times 5, and that's it. And the 25 is equal to 5 times 5. So we know 40 over 25 is actually 2 times 2 times 2 times 5 over 5 times 5. So let's cancel a pair of 5's. And what's left is 2 times 2 times 2 is 8, and the bottom will only have 5 left. So our final answer for this question is 8 over 5. Okay. Yeah, so that's it for this section.